In this video, I'm going to try to clarify something that may have been confusing in the previous video. We had worked through the problem, the limit as x tends to 0 of 1 minus cosine of x divided by sine x. And if you'll remember, we were trying to use these limits here, 1 minus cosine of x. Limit as x tends to 0, 1 minus cosine of x divided by x is 0. And this limit, that limit as x tends to 0 of sine x over x is 1. So we re-express this as we multiplied and divided by x, right? And then what I said is we could rewrite this as x over x, 1 minus cosine of x divided by sine x is you can see that it's the same thing as 1 minus cosine of x times 1 over sine of x, because dividing by something is the same thing as multiplying by 1 over it. And now to the part that may have been confusing. I said you could regroup this in this fashion here. So you could put this denominator underneath 1 minus cosine of x, and you could put this numerator on top of 1 over sine of x. And I'm going to show you why that is using this calculator here. Okay, so now I think I have the calculator working. Let's say we were working out 3/8 times 5/7 times 2/3. And we get this decimal here that's approximately 0.1786 to 4 decimal places. Now instead of 3/8 times 5/7 times 2/3, what if we swap these denominators here and we said 3/7 times 5/8 times 2/3. Oops, I made a mistake. I did 3 times 7. 3/7 times 5/8 times 2/3. You'll see we get this same decimal here, even though we put the 7 under the 3 instead of under the 5, and we put the 8 under the 5 instead of under the 3. We just swapped these denominators here, and we still got the same answer. Now let's say, what if we made 2 swaps? So we did 3/7 times 5/3 so we accounted for a 7 in the denominator, a 3 in the denominator. All we have left is a 2 in the denominator to account for, times 2/8. So we made 2 swaps here. and you'll see we get the same decimal that we did in both the other cases we examined. So this is pretty much the same thing. Let me go ahead and close out. Well, I guess I can keep it up here. So here, instead of so this is 1 minus cosine of x over 1, and this is 1 over sine of x. So all I did was well, actually, let me go ahead and make one more quick point here. Now, let's say there's another way to compute this. We could multiply all the numerators out here. So 3 times 5 times 2 and divide by all the denominators multiplied together. 7 times 3 times 8. If I did that right, hopefully we'll get we get the same answer. But now let's say we switch the order here. We say 5 times 3 times 2 divided by 3 times 7 times 8. You'll see we still get the same answer. So as long as what is a numerator still remains a numerator, and what's a denominator still remains a denominator, we can flip the order, we can switch the order as much as we want. And so going back to the example we were working with here we had an x in the denominator. So I said let's just put the x under 1 minus cosine of x. And then we had an x in the numerator, and I said let's just put it under or over sine of x. So what happens to these ones? Well, this is just 1 over 1. So another way to write what we had here, remember the only important thing was that what's a numerator remains a numerator. So we could say x times 1 minus cosine of x, and this is still the limit as x tends to 0, times 1 divided by x times 1 times sine of x. Okay, and we can split up the order any way we can change the order any way we want here. So let's say we were to flip these two in the numerator. Said 1 minus cosine of x times 1, and in the denominator let's just say we interchange. Well, let's see here. Yeah, in the denominator, let's say we just switched sine x and 1. We kept the x first, and we swapped the sine x and 1. So x times sine x times 1. So now we can just write these over there. We can split these up into 3 fractions multiplied by one another. This is no different than splitting up 3/8 times 5/7 times 2/3, or sorry, this is no different than splitting up 3 times 5 times 2 divided by 8 times 7 times 3 into 3/8 times 5/7 times 2/3. And you saw, based on what I showed in the calculator, these were equivalent. These gave you equivalent decimals. So that's all we're doing here. This 1 minus cosine of x, I'm just going to put it over x. X, we're going to put it over sine x. This 1, we're going to put it over 1. And this limit here of a product is the product of the limits. So this is limit as x tends to 0, 1 minus cosine of x over x times the limit as x tends to 0 of x over sine x times the limit as x tends to 0 of 1. And we know this limit is 0 here. Limit as x tends to 0, 1 minus cosine of x over x. And this is the limit as x tends to 0 of 1 over sine x over x. And of course, this limit as x tends to 0 of 1 is just 1. And so the limit as x tends to 0 of 1 over sine x over x is equal to 1 over the limit as x tends to 0 of sine x over x. And this is just because the limit of 1 over something is 1 over the limit of that something. This just stems from the power property, because this is sine x over x to the negative first power. So the limit of this function to the negative first power is this limit of the function to the negative first power. So here, instead of raising it to the negative first power first and then taking the limit, doing that is equivalent to taking the limit and then raising it to the negative first power. Hopefully that makes sense. And we know this limit is 1, so we have 0 times 1 over 1 times 1, and that's just 0. But the main point was to show you why you could go from here, the limit as x tends to 0, x over x times 1 minus cosine of x over 1 times 1 over sine x. And, or really it was here we had multiplied and divided by x, and then we rewrote 1 minus cosine of x divided by sine x as 1 minus cosine of x times 1 over sine of x, because dividing is the same thing as multiplying by 1 over the reciprocal of something. And yeah, so the main point was to show why we could go from this here to this here. And that's why I brought up all those rearrangements of those products of fractions on the calculator, and showed that as long as what's in the numerator remains in the numerator and what's in the denominator remains in the denominator, You can change the order as much as you want and you will be okay. So hopefully that clarifies what I'd said in the previous video.